Okay, today we're going to be starting a series of lessons on integration, and we're going to be going through the integrals of exponential functions, logarithmic functions, and trigonometric functions as well. So doing as you know before, integration is opposite of differentiation, so all the different things we've been learning with differentiation, all the different identities, we're going to be learning the integral equivalent of those. So to begin with, we will start with exponential functions. So let's just do a wee recap. We know that the derivative of e to the x is just e to the x, and we know the derivative of e to some function ax plus b is the derivative of this function, so that would be ax plus b. So that therefore can give us some indication of how we would go about finding the integral. So if we just had the integral of e to the x dx, that would just be e to the x, because the derivative is the same of e to the x is just e to the x. But remember, when we find the integral, you need to have this constant of integration, because if you had a function, so you had a function e to the x plus some constant c, when you differentiate that, that falls out. So we need that constant of integration. The integral of e to the ax plus b dx is going to be the opposite of this, so 1 over a e to the ax plus b, and then again our constant of integration. So let's do some examples. So firstly, we're going to find the integral of e to the 3x dx. So that's just going to be the derivative of this would be 3, so we do 1 over 3 e to the 3x plus c. The integral of e to the minus 2x dx, again we would take the derivative of that and then 1 over, that's what's 1 over minus 2 e to the minus 2x plus c. The integral of e to the 5x minus 4 dx, so the derivative of that would be 5, so we do 1 over 5 e to the 5x minus 4 plus c. All very straightforward. Let's evaluate between 1 and 2 the integral of 9 e to the 3x minus 1 dx. So the first thing is, when we put it into square brackets, we'll find the integral of this. So it would be 9 over, the derivative of 3x minus 1 is just 3, so that's going to be 9 over 3 e to the 3x minus 1. Now when we're doing, when we're finding the evaluating an integral, we don't have the constant of integration, so you'll have between 1 and 2. And now we're going to, so 9 over 3 is just 3, and now we're going to slot in the value. So we do the 2 first, so it's going to be e to the 3 times 2 is 6, minus 1 is 5, and then minus 3 to the e is 1, so 3 minus 1 is 2. And we will simplify this down, so we'll take the 3 out and we'll take e to the 2 out, and that's going to leave us with 5 to the power 3 minus 1. And we'll just leave it at that because the answer is going to be something really messy. Now if you remember, the integral of something is when we evaluate it, we're actually finding the area under the curve. So if we've got set these limits here, 1 to 2, I want to find this area of y equals x squared plus e to the minus 2x. We want to find this area, so we'll find the area is going to be equal to the interval between 1 and 2 of x squared plus e to the minus 2x dx. So that's going to be, we'll integrate this first, so that will give us x to the power 3 over 3, and that'll be a minus. Let's just do the minus here, so it's going to be minus a half e to the minus 2x. That's between 1 and 2. Then we're substituting in for our value of 2, so it's going to be 8 here over 3 minus a half e to the minus 4, and then we minus this, and then it's going to be a third minus a half e to the minus 2, and if you juggle that into your calculator, you'll get 2.39 units squared. So I hope that helps.